All right, let's dive in. Today, we are going to deconstruct complexity itself. We're going to look at three gigantic, seemingly unrelated systems, an operating system, a symphony, and, the entire structure of science, and try to find the one powerful pattern that explains how they all actually work.
I mean, really think about that for a second. You're starting with nothing, just a blank processor, with the pros called bare metal. And from that, you have to build up the entire world of windows and icons and multitasking that we just take for granted every day. It feels completely impossible, right?
Or what about this? How do you take just 12 simple notes and arrange them into a symphony? A piece of music that has structure and tension and this emotional power that can move thousands of people. Where does all of that come from?
And here's maybe the most ambitious one of all. How do you even begin to structure all of human scientific knowledge, from the basic laws of physics all the way up to the insane complexity of biology, into one coherent, reliable system for understanding reality?
All three of these things, an OS, a symphony, science, they can really feel like magic. But they're not. They are built systems, and that means we can take them apart. So we're going to strip away all the layers and start where every single builder has to, at the absolute bottom.
So this first stage, we're going to call it the bare metal foundation. Every complex system, and I mean every single one, no matter how grand, is built from just a few non-negotiable first principles. You could call them atoms. The tricky part is, first, you have to find them.
Okay, so in OS development, you hit this weird paradox right away. The tools you normally use to write code, like a compiler, well, they need an operating system to even run. So your very first step is to build a special tool, a cross-compiler, that can create your new world without having to stand in it. You literally have to forge your own tools before you can even start the work.
And this just brilliantly illustrates the mindset you have to be in. This quote from our source material on OS engineering absolutely nails it. The first step isn't about coding the system. It's about realizing that you can't use the assumptions of the old world to build the new one. You have to start from scratch, from first principles.
So once you have your tool, you have to make a huge foundational choice. In the OS world, this is your boot protocol. Are you going to start with the old-school BIOS system, which forces you into this clunky 16-bit mode, or are you going to use a modern protocol like Limine that lets you jump straight into a 64-bit environment? This one choice dictates, well, pretty much the entire architecture of your kernel.
And believe it or not, that exact same kind of trade-off exists in music. Here, the big foundational choice is your tuning system. Do you go with just intonation, where notes are based on these pure, perfect mathematical ratios? It makes one key sound incredibly beautiful, but other keys sound, well, terrible. Or do you use equal temperament, where every key is just a tiny bit imperfect, but they're all functional? It's the same core decision, purity versus flexibility.
And in science, what's the foundational atom there? It's the falsifiable hypothesis. This is the absolute, non-negotiable starting point. A claim is not scientific unless there is some way to test it and, potentially, prove it wrong. You just can't build knowledge on claims that can never be invalidated. This, right here, is the bare metal of science.
Okay, so you've picked your atoms. Now what? Well, you need rules. This next layer of complexity comes from creating a simple, repeatable structure to organize all those fundamental elements. Back in our operating system, one of the very first structures you create is something called the Global Descriptor Table, or GDT. Now, it looks complicated, I know, but it's really just a simple rule book. It tells the CPU, hey, this chunk of memory is for kernel code and this other chunk is for kernel data. That's it. It establishes the most basic rules of the road for how memory can be used.
The musical equivalent of this is a rule like tertian harmony. This is the simple recipe for most of the chords we hear every day. You pick a root note, and then you stack other notes that are an interval of a third away. C, then E, then G. That one simple, repeatable rule is the foundation for almost all of Western harmony. It's that simple.
And in science, the rules for structuring knowledge, well, they distinguish between laws and theories. A law, like F equals ma, is just a concise description of what happens. It's a pattern we observe. But a theory, like the theory of evolution, is the much broader, evidence-backed explanation for why that pattern exists. They're just two different types of rules for organizing what we know.
So we've got our atoms, and we've got our rules. And this is where the magic finally happens. This is the phenomenon of emergence, where simple little components interacting under simple little rules create complex, unpredictable, and powerful behavior that seems to come from absolutely nowhere.
I love this quote from our music theory source because it just captures the idea so perfectly. A melody isn't just a list of notes, right? It's an emergent property. It has a shape, a feeling, a character that doesn't exist in any single one of those notes on its own.
So in our operating system, the most powerful emergent property is multitasking. That feeling that your computer is playing music and browsing the web and running a chat client all at the exact same time. But here's the secret. A single CPU core can only do one thing at a time. So, how is this illusion created?
Well, the answer is a really simple rule called a context switch. The OS literally pauses one program, saves everything about it, loads up all the info for the next program, and lets that one run for a tiny fraction of a second before switching again. It's just jungling, very, very quickly.
And how quickly are we talking? This switch, this juggling act, happens over 100 times every single second. From that one simple rule, executed at an incredible speed, the entire complex experience of modern multitasking just emerges.
And in music, we see the exact same thing with groove. You know that feeling. Groove isn't something one person plays. It's that kinetic energy that emerges when the drummer, the bassist, and the guitarist all lock their simple patterns together perfectly. It's a property of their interaction.
And for the ultimate example, life itself. The simple rules of chemistry, how atoms bond together to form molecules, give rise to the almost unbelievable emergent complexity of biology. The entire living world is an emergent property of chemistry.
So we've gone from bare metal to atoms to rules, and finally, all the way to emergence. And when you understand this progression, you get what we can call the builder's mindset. It's a way of seeing the hidden structure beneath the surface of any complex system.
This is the path. This is the blueprint. First, you identify the absolute, non-negotiable fundamentals, your bare metal. Then, you apply simple, repeatable rules to organize them. And finally, you just step back and allow complex, emergent properties to arise from that interaction. This is the pattern that builds worlds. So I'll leave you with this question. Think about it. Whether it's the company you work for, or the traffic patterns in your city, or maybe even a creative hobby you have, what system in your life that feels like magic can you now deconstruct into its atoms, its rules, and its emergent properties?